Hello folks, we are once again back with our next video where we are doing the problem number 17. I don't know whether we'll be able to take the next problem also. Let's check. So that's how this is. So it prompts us that if you have this e raised to x times something, we have to convert this term x over 1 plus x the whole squared as f of x plus f dash x, but it is not in that form. It's very clear that it is not in that form. So what we are going to do is we are going to take this function and we are going to work with it and we are going to make it look like f of x plus f dash x. That's going to be our work. So always this idea should be there in your mind that whether we are able to convert it in the type f dash x plus fx. If it's not, then you'll have to use integration by parts and do your work. But if you're able to convert, then you really have an easy result and very easy to do the integral. So that's going to be our work. Let's check if we can by any chance make it in the form fx and f dash x, fx plus f dash x. If that is the case, then you can get the integral directly. If you're not able to do it, then we'll go for integration by parts. So let's only consider this and let's see if we are able to do any manipulation there. X over 1 plus x the whole square. Now writing x over 1 plus x the whole squared is as good as writing 1 plus x minus 1. Why? Because the plus and minus, they'll cancel each other and you're left with x. By doing this, you get one important convenient form, that is we could write this like this. We could separate and write, this as one and this as the other. Of course, because you know that there is a denominator. If there's a denominator, then that denominator applies to all the term in the numerator equally. So we club these two terms and we club that term and we put it like this. Now what's the advantage? The advantage is that this can cancel each other and this will become 1 over 1 plus x, and here it will become 1 plus x the whole squared, or if I want I could write it as 1 plus x plus minus 1 over 1 plus x the whole square. Absolutely okay. We could write it like this. Now why we wrote it like this? So that this can become fx and this can become f dash x. Let's see how. So here, let's see here, the f of x, you assume it to be 1 over 1 plus x and look at its derivative. So how do you take the derivative? You look at it as 1 plus x raised to minus 1 because it's in the denominator. Then nx raised to n minus 1. So it will be minus 1 plus x raised to minus 2, and then you have to account for the differential coefficient, but because it is x, there is nothing that is going to contribute. So this is going to be your differential. It's going to be minus 1 over 1 plus x the whole square. That's exactly what you're getting here. So here you can treat this as fx and you can treat this as f dash x. So from 1, so therefore I becomes what? It becomes e raised to x times 1 over 1 plus x plus minus 1 over 1 plus x the whole square dx, and that actually is e raised to x times 1 plus x plus c. That's it. That's the integral. And why we got this? We got this because if at all you have an integral which is of the type e raised to x times fx plus f dash x, then the integral is just e raised to x f of x plus c. So you may not have it directly, but it can be convertible, and once it is converted, your work is so easy. Otherwise, if you would have taken integration by parts, it would be really difficult because ILATE. So you have to treat this as algebraic, exponential, and then lots of work. So this will make the whole thing really, really easy. So quickly, without wasting any time, let's go to the 18th one, which is also somewhat in that lines. Let's see what does it say. It says that it is e raised to x times 1 plus sin x over 1 plus cos x dx. Integral you have to find. Again, it's the same story because it's not directly available to us, but it can be convertible, and then you can have this fx plus f dash x business. So let's see now how you can do it. So let's consider, okay, let's consider this part first. Consider 1 plus sin x over 1 plus cos x, which we could break and write it as 1 over 1 plus cos x and sin x over 1 plus cos x. Now we have all learned the trigonometric formulae and we know that 1 plus cos x is 2 cos squared x over 2. So let's make all that conversion. This is going to be 2 cos squared x over 2. Here also 2 cos squared x over 2, sin x is 2 sin x over 2, cos x over 2. As a result, one of the causes and 2 is getting cancelled. So this can become tan x over 2. Why? Because the other things have got cancelled. And this, I can write it here. It is 1 over 2 sec squared x over 2. But incidentally, this is the differential of this function. So let's observe that here f of x, if you could take it as tan x over 2, then when we try to write the differential, it is going to be tan's differential is sec squared x over 2, but because x is having that half with it, that half we have to account for. So that's how we are getting it as f dash x. So therefore, let's call this as 1, then from 1 you can have the I. I, what does it become? I becomes, it was this that we had, so it will become e raised to x, but we have got this converted as tan x over 2 plus half sec squared x over 2 dx, which is clearly e raised to x fx. So that means it is e raised to x tan x over 2 plus c. That's all. So that's about it. So it's going to be e raised to x tan x over 2. I need to check sometimes, sometimes suppose it, yeah. So that's all for us. That's how we get this. We have more problems. Let me see. Yeah, there are some more problems that is there. So with those problems, I think we can meet in the next video. So that's all for the video as for now. As I always tell, please popularize the channel, please spread a word amongst your friends. See that we have so many subscribers and the channel is utilized all over by students, and it will be solely by your efforts. Thank you.